As we're learning in our study of energy this year, certain things or certain terms have particular meanings, and this is presenting problems with us. And so let's look at this one. We've been looking at it over the last couple of lessons, and it's a thing called work. All right, so what actually is work? Well, most of us associate work with the general or generic meaning of something like this one, an activity involving mental or physical effort done in order to achieve a purpose or result. In other words, it just is this generic and general sort of idea that we're actually trying to do something, and by trying to do something, we're doing work. Now, most people in society would accept that as a very, very good definition of work, but maybe we need to think about it in terms of physics. So if we look at work in terms of physics, we must bring in the idea of energy. Hence, it is there. And so what we're talking about is transferring to or from an object with the application of force along a displacement. Oh my goodness, that's a mouthful. But what does it really mean? Well, the second one says it all. So it talks about the energy used in applying a force to move something over a distance. So when we're talking about energy in terms of physics, and for the whole purpose of this course, when we're talking about this whole idea of work, we're talking about moving something. So in physics, if you push and groan and shove and poke at a wall and it doesn't move, you've done no work. If we think about it in terms of a generic societal version of it, you've done a heap, you've applied the effort. But don't get them confused. So when you're doing it, we must be talking about we're actually physically moving something. And that requires energy to do that. And that's the tie-in. Now, we've noticed that there's an equation that goes with it, and lots of W's, unfortunately, in our form. We've seen there's work and there's watts. Oh, goodness gracious me, there's quite a few. So anyway, let's look at it. In our case, work is the amount of work we've done is equal to the force we've used times the distance it's applied over. All right, now put it here. Now, these things must be true. As with everything in our course we've done so far, we've seen that certain of our quantities have to be in particular forms. For example, mass has to be in kilos. Right, distances have to be in metres. Right, so in our case, we're talking about work in joules. Notice it's the same unit as we have for energy. Maybe there's something in there. F, capital F, is the force in newtons, capital N, and distance is the distance in metres that you've actually moved this thing over. We'll get in and have a couple of examples of this a bit later on.